Welcome everybody to the fifth PDC language panel. We have been doing these language panels since the PDC in 2000 when .NET got announced. And I'm really happy today to have this kind of super panel here of language experts. Anders Helsberg doesn't need any introduction. I heard that everybody loved his talk. Well, now we have even more great people here, so you will even love this talk even better. So I'm pretty sure that this panel will get a 4.0 score. And I don't think that has ever happened at the PDC. So perfect score, that's what we're going for. Next to Anders, we have Gila Braga. Gilad, you might know him from his Java work, but now he's doing very interesting stuff on dynamic languages, and we will hear much more about that. Douglas Crawford. Anybody here that, probably everybody here uses JavaScript, so you probably have read his book, and if you don't have it, get it. I don't know if they have it in the bookshop here. Great book, great guy. We will hear a lot from him this time around. Wolfram Schulte represents research, the, all the kind of, cool stuff that's there in the future. And then we have another kind of half researcher, kind of, language, polyglot, Jeremy Seek. He is like in the C++ committee, and he's doing stuff with Python and doing with Haskell, so there's no language that he hasn't looked at. I think Jeremy is the rising star of the young language designers, so keep an eye on him, not only today, but in the future. All right. So the way the panel will work is we will start with some questions I have here in my big book. A lot of questions, but I hope that I don't have to use them all, because kind of halfway through we will open the kind of floor for the audience, and then you can ask questions. But just to get things kind of started, get the discussion up, get things heated up, I will ask a couple of questions. So my first question to all the panelists, and this will give them...
Oh, gotta turn that.
So the first question, which gives the audience, or sorry, the panelist an opportunity to introduce themselves, is the following question, and I would like to hear kind of short answers from everyone. Is what do you consider to be the kind of most pressing problem in the industry today, and what is your language doing to kind of help solve that problem? Let's start with Jeremy and then go from left to right. So Jeremy, what is the biggest problem that we face, and why are you kind of the guy that's solving this for everybody here?
Okay, well, probably everyone's expecting me to say something about, it starts with an M, and multi-something, right? But I think maybe a bigger problem is that we're all using all these frameworks, and we're getting all kinds of code reuse, but now we're sort of suffering sort of a second-tier kind of effect and problems from that. So how do you get these frameworks to work with each other? How do you keep them in sync? How do you keep modularity? When you've got maybe you've got a bug inside of one module, how do you find that before you deploy? One of the big problems we have in C++ is we have all these template libraries that are wonderfully reusable, but we've got this horrible situation where when people go and use these libraries, the error messages are just infamously bad, and that really breaks the modularity. You're seeing into the guts of these libraries. So I think figuring out how to get better modularity, better encapsulation with all these frameworks is one of the biggest problems we need to face.
Okay, Wolfram. It better be kind of,
Okay, so I think biggest problem is the complexity in our code and how we can control it. And so in research, we have worked a lot on reliability techniques from static analysis, dynamic analysis, testing. And ultimately, it comes to language design, right? If we actually allow arbitrary programs, we can expect arbitrary bad responsiveness, security holes, and so on. So I think there's lots of things to do.
And so, but what kind of do you do to kind of, kill the complexity monster?
Okay, so in some sense, since most of you are using existing programming language, we can't move you all completely into a new world very rapidly. So what we do instead is we build lots of analysis tools that are in some sense like grammar checkers for Word. They actually figure out where you make your errors while you're typing.
Okay, and Doug?
There are clearly lots of opportunities for improvement, all over the spectrum, dealing with complexity, dealing with multiplicity, and all of those issues. But I think the biggest problem that we're dealing with currently is insecurity, particularly as we get more and more networked and as we get more and more distributed. The consequences of insecurity are getting greater and greater. And I think we need secure programming languages in order to help us deal with that. Ultimately, everything we write is going to ultimately be secure applications. Someday we'll all be insisting that our operating systems be designed with and implemented with secure languages. It's the only thing that makes sense, and we should be demanding it now, except it's kind of pointless to demand it now, but ultimately, that's how everything's going to need to work.
And so what are you doing specifically to kind of make the world more secure? Is there any kind of solution that you have to offer?
So perhaps unexpectedly or perhaps ironically, one of the languages which is on the forefront of this work is JavaScript, which is a horrendously insecure language, but actually has some good guts. And I'm working with ECMA to see if we can determine a secure dialect of ECMAScript in order to allow us to do safe web applications.
So is that anything related with the web sandbox that was kind of, announced here? Or?
It's definitely related. Scott Isaac's work on the web sandbox is amazing, really clever stuff. I'm working with Scott on this, also working with Google's Kaha team, my own work on AdSafe. We're all looking at what we can do in order to make JavaScript a safe language. It's feasible because there's some goodness in the language, surprisingly. And if we can remove enough of the bad parts, I think a secure language is obtained.
Okay, well, that's great to hear. That's like, in the spirit of the web, that kind of different companies are collaborating in this space. Gilad?
Well, I'd say all of the above. But this whole business of web programming and the cloud and how you actually continue to program at a level that's as good or better than what you're used to on a conventional platform, rather than regressing to this world of DOM and CSS and 17 different components that you have to mix and match, and JavaScript without decent debuggers and all these issues. I think we need languages that are designed to work in a networked world and let you do things that work well on a local platform and take advantage of the network. So we're not necessarily regressing to time-sharing 1960s style with the cloud, but actually taking advantage of both personal computing and the network, and making languages where you can program at a high level and still take advantage of these tools of being able to run this code in a web browser or locally, and features that help that. That's what I'm working on, and I think that it has a lot of potential and could help a lot of people just make their life better because it will be more pleasant to work that way and produce more productive and more secure results.
Okay, great. And Anders?
Well, I'm surprised it got this far and no one said concurrency. I mean, well, I guess we sort of started out. I do think, I know that we keep talking about concurrency. I still think it's one of the biggest problems facing us right now. I mean, and it's interesting to see how we're making progress in DSL tools, we're making progress in, all sorts of surrounding issues, but the core hard problems of concurrency are kind of still there, and the onus is upon us more and more to come up with some better solutions, because concurrency is too hard as it exists in the mainstream today. So I think there's still a lot of work we have to do there. I think in a sense also as language designers, it's like one big problem might be how we avoid disappointing programmers continuously, because languages move a lot slower, I think, than most people expect. There's always this, in 10 years we're all gonna do DSL models and we're all gonna do this and that, and well, you know what? We're all going to probably still be writing text files, and it's just not going to be quite as rosy as because programming languages evolve quite slowly. So hopefully we won't disappoint too much.
So you bring up an interesting point there, because we heard a lot about modeling, and my question is, like, what is really the difference between modeling and programming? Is there a difference, or is there no difference, and why? Why do people want to make a distinction between the two? So anyone in the panel has an opinion about that?
I'm happy to go first. I think modeling is actually different than programming. In the past days, we have seen M that was presented as, in some sense, a nice form to write abstract syntax. But ultimately, you have to say that a model only typically describes part of the world, right? A model for an architecture is typical. It's probably the structural properties of a building. It's not about the heating system. And so what we do with models is actually looking at partial solutions to really understand what goes on. And then maybe we combine different models to get the overall picture so that we can finally build a real system. So there is a difference. Whereas when in program, we rarely separate out all the different aspects. We glue everything together, and that's what we get. So there is definitely a distinction. And models are typically also work on a much higher abstraction level than the ultimate code.
So you're supposed to have controversy in a panel. So of course, Wolfram is completely wrong. And the thing is, modeling and programming are the same thing. A program is supposed to be a model of some part of the world or some part of a virtual imagined world that you create. And you should be able to interact with it like in a model. The problem is that the languages we have are lousy for modeling or for anything else. And so we tend to look for special tools that do this better, because they're just not high level enough. And very often they don't let you interact with the model. You build this thing, it runs, and it's very difficult to interact with it, right? You cannot, for example, run your program backwards in time and find out what happened. In most systems, you can't change your program on the fly and see what happens if I do this. You can't do these kind of what-if experiments very easy. There are programming languages and particular environments that let you do that to some degree, and I expect we'll see a lot more of them.
The question reminds me of some of the history in this field. In the late 1950s, there was work on a concept called automatic programming, recognizing that programming was just too hard, and so we needed to have some higher level way of specifying what you needed done so that the computers could write the programs for you. And the result of that work was Fortran. It turns out, programming is too hard, and so we keep trying to push up to some place where it's not so hard, but eventually that becomes programming too.
Yeah, I think it's probably more a question of what are the semantic capabilities of what you're programming. And when people say programming, they tend to mean general purpose programming language. When they say modeling, they tend to mean a DSL, so. Yeah. But they are both forms of coding or programming, if you will.
But one question is modeling is it inherently a higher level of abstraction than programming? And it doesn't have to be. So, I mean, a lot of us have this notion of sort of programming in one low level of abstraction, but with all the advances in object-oriented technology and things like that, we can build classes, we can build methods, we can build higher levels of abstraction, and we can have one layer on top of each other. And at the very highest level, why not have things that are exactly the same level as the models that you're building?
Okay, I think I'm here in the minority, so I'll fight as hard as I can. So I don't know whether you have actually ever built real-time systems. But if you build real-time systems, then you use Simulink or MathWorks in order to describe just continuous systems. And then and that's only part of the control system, right? And then you still have to allocate your resources. But that's a completely different aspect. A completely different aspect if you build real-time systems is actually the timing behavior, the rates under which you have to accept events or have to activate actuators. And you really want to separate that out, because if you build all the complexity in one system and then you say, okay, this is a high level and it does everything for me, it doesn't work. Another area that I think is very nice in this space is there's the idea of design space exploration. So you have, in some sense, a model that describes your system, and you have some controller, and you have the timing behavior, and then you have some hardware devices. And then you want to make sure that the way that you map all the processes on the hardware actually guarantee that the timing constraints will work out. And so this is really separate models bringing together, optimizing then the mapping onto the hardware. And while we talk mainly about programming language, these engineers are actually writing lots of stuff that end up ultimately in software. So I don't think that we should only look at UML or M. We should broaden our space a little bit, and then we see lots of models that people are using, and that not complete programs.
Okay, so now you touched on an interesting thing, UML or M or something. One thing that kind of, excites programmers more than anything else is syntax. Even though I think we should kind of care more about semantics, but we do care about syntax. So, and often people say that syntax kind of, might be the reason why a language succeeds or not. So, for example, the fact that JavaScript syntax looks like Java, and that Java syntax looks like C, made that successful. Or maybe people, when they look at BASIC, they don't like the wordiness, or other people really love that. So, and Smalltalk is another example that has kind of some exotic syntax. So, what do you think? Is syntax important, or is that just kind of fluff that really should not matter?
Oh, I think it matters a lot. I mean, I think it's our brain is a pattern recognizer, and syntax is one of the patterns that we feed in, and that triggers certain neurons, that when you see code with curlies, you kind of think in an imperative way. When you see, sort of math notation, you think more functionally. I think syntax is it's amazingly important, actually, and syntax does matter. Yeah.
Okay, Gilad?
It does and it doesn't. How's that for a waffly answer? In sort of terms of adoption and so forth, it matters because people are trained to certain syntax. They're just by historical accident or whatever, there are certain notations that people have learned to recognize, and they're immediately familiar, and people can learn them. They're generally not willing to take a few days to learn a different syntax, even if once they overcome that barrier, they may find it works better. At a fundamental intellectual level, it really usually doesn't matter at all, and it's kind of Parkinson's law of triviality applies here, right? The fact that the smaller the issue, the more people discuss it. And so, where you put your semicolons, everybody has an opinion. It's the bike shed problem, right? When you build a nuclear reactor, building a nuclear reactor is complicated. You don't really know what to say, but you can discuss where the bike shed will be and what color it'll be, because that you understand. So people who don't want to worry about the complicated semantic issues can obsess over whether there are semicolons or dots or whatever. But it is a triviality. That said, it's very important, and sometimes, technically some syntaxes work better. For example, Smalltalk syntax actually works better in dynamic languages because you can't get arity errors, unlike, say, JavaScript. So the C notation actually works poorly for dynamic languages, but it is so familiar that people would rather bang their heads against these errors than learn something new.
Taking that a bit further, we like to imagine that the process of programming language design is a scientific process, or at least an engineering process, but it's really all about fashion. Dressing it up with stuff which looks attractive to you, basically. If we don't do that, then the language will not be attractive.
Being the fashion connoisseurs that you are.
Yes.
Indeed I am. And it's odd to talk about fashion in describing the nerdliest of arts, but in fact I think the success of languages has more to do with fashion than the quality of the ideas behind them. I think that's unfortunate, but I think it's real.
Okay. When I was young, I was also involved in language design, and I was very passionate about syntax. And if you're actually getting older, you care more about the inner values of things and don't care so much about the outer appearance. And I think let's leave it at that.
So I think Eric has the right idea when it comes to fashion. Do whatever you want. Do your own individual fashion. So how does that relate to the syntax in languages? Well, we should be able to extend the syntax as a programmer. You shouldn't have to be a language expert. You shouldn't have to be the guy, at Microsoft or at Sun or whatever in charge of the language to be able to extend the syntax. So maybe kind of like a question, to kind of step back for a second. Like, what's the difference between creating a new library versus creating a language extension? In some sense, both things are about creating some kind of new abstraction and a new level of thinking. And the only main difference really is that with the language extension, you get to extend the syntax and you get to extend how the debugger presents that kind of abstraction. But why can't we do that for libraries? Why can't we have that kind of extensibility built into our general purpose language to make our libraries more like language extensions? Yeah.
Oh, that's a very popular standpoint, so I'm going to attack that. So isn't it very dangerous to have like amateurs kind of, pimping the language and changing it in arbitrary ways? That's one thing. And the other thing is like if everybody can change the syntax or add to it, now you can never learn the language, because every time I see a program, I have to kind of learn a new language. So everybody's brain will explode. So that will be a really ugly sight.
Fear, uncertainty, and doubt. You're getting old, Eric. Viva la revolution. Yeah. No, seriously though, as humans, we're coming up with new notations, new abstractions, new languages all the time. And so, in some sense, I think when you try to limit that, you actually get weird things happening that are weirder and sort of harder to deal with than if you just let the language extension happen naturally. So, for example, in C++, we have, you can't literally do any language extensions in terms of syntax, but we have all these operators. And we can do weird things with operators, and we can combine them in all kinds of strange ways. And why do we have to do that? It's because we can't do the natural thing, We can't, let's say you're a physicist and you want to express the absolute value of something. You want to put a bar on either side. We can't do that. So instead we have some, other things that we do instead. So I think we actually are hurting ourselves by not allowing full language extensions.
So you're saying that the language, in terms of its expression, is so horrendously impoverished that you need these other mechanisms?
No programming language that I know of in mainstream use allows sort of arbitrary syntax extensions.
Well, and I think that's a good thing, to your point. Looking back, Forth was a language which did. The process of Forth was basically designing a language that was ideal for solving your application. It looked like a really good idea, and there were a lot of people who were really passionate about that language. How many people here are using Forth?
Ooh, wow. One at a time now.
That's a straw man, though. Forth there's all kinds of other reasons why Forth isn't going to make it.
But that was a language designed specifically to do the thing you're describing.
Okay.
Rather than bolting something onto a language which wasn't intended to have such a thing.
But
Anders, you must get this request.
Oh, I get this request
right?
a lot, and we actually did sort of the mind experiment in C# 3.0, because with C# 3.0 we built a DSL called Link, which uses the fluent interface style or fluent method style of dotting together things, and you're passing code as parameters through lambdas, and if you squint, you can sort of see a query language there between the .wheres, .selects, .orderbys, and so forth. But of course, people wanted it to look more query language-ish, SQL-ish, if you will, and we ended up adding query comprehensions or query expressions, the from, where, select, manifest syntax in the language. But obviously we thought about, well, gosh, if we can define the API, why can't we define the syntax that goes with the API as part of the same process, right? But it turns out to be pretty complicated. You kind of want to isolate yourself. Ideally, the language would be rich enough that you could also define the syntax, right? So that would kind of be like macros or hygienic macros or whatever. But it turns out that, like with Link, for example, there are some pretty interesting semantic things that happens there. You know, it's not rich enough that you could do it in a macro language and have it be type checked. So now, before you know it, you know, you dig down and you discover that, well, we would have to open up the compilation process, expose all of the ASTs, and allow people to plug in code everywhere in the compiler, and then you could do anything, right? Except evolve the language. and so now we have this dilemma that what do we do? I mean, I'd love to do this, but the minute I do it, we're done, because the process of compilation becomes so exposed and intertwined in user extensions, and you could never modify anything without breaking everything. So it's a tricky problem. We continue to think about it, but I don't know what the answer is.
Before I give you another chance, I want to hear from Gilad, because people often say that the Smalltalk syntax with the kind of the keywords kind of interspliced in the method calls kind of gives you that capability, right?
Well, it gives you something in the middle, which I think is the right answer. I think what will come out of inexperienced people making their own syntactic extensions, which with the freedom to do it, and technically it's actually, there's work that shows actually reasonable ways to do this. You probably won't be happy. I mean, one theory of giving people what they want is, give them enough rope and then they can string themselves up whichever way they want. But I don't think that's a good idea. But on the other hand, what happens with the mainstream notation to which most of you are so passionately attached is that it is really designed to do one thing and one thing only. And it has a lot of noise in it that gets in the way the minute you try to do a domain-specific language that's a little different. Because it tells you there's a lot of extra noise which says you should pass your parameters with parentheses and you need a dot here and so forth. And just having a less noisy syntax tends to make it much easier to embed and to use operators, for example, to make a library that actually does behave, look a lot like a domain-specific language. And maybe it isn't the exact syntax you would have designed as an external DSL, but you get a huge advantage of an internal DSL, which is all your tools work, all the facilities of your IDE work with it. You know actually what it means. And we've done that, and yes, and if you want to do more with it, you can actually build a DSL, and yes, you can open up the compiler and the AST and so forth. And that was done, 30-something years ago in Smalltalk, and sort of the original open source in that way. The language generally hasn't changed much because it actually worked the first time. But nevertheless, there are issues with it, and one could have a long discussion why it didn't work. And syntax is part of the reason it didn't succeed, but there are others, and which is why I'm in the process of reforming it, as it will. But you do get this ability to embed DSLs very easily without arbitrary syntactic changes, just by having a well-designed initial syntax that is less noisy, and it's different, alas.
It didn't work the first time. Smalltalk 72, 74, 76. I mean, they fiddled with it for 8 years before they got it right. But I think
how long have they been fiddling with C++? And they never know when to stop fiddling?
Yeah,
there's no end in sight.
In 80, they got it right.
Yeah.
So, yeah.
So maybe I'm the theoretician here, but one of the funny things is that we struggle with domain-specific language because our missing abilities to do parsing very well. And in some sense, that's ridiculous. We should have actually made more progress, but in some sense, the need for domain-specific languages wasn't probably as apparent as it is now. So maybe we should go back and figure out how to do that well, and then actually allow extensions to a limited degree. So really have embedded domain-specific language where you can't do arbitrary stupid stuff. But you can at least get some of the flexibility.
So Jeremy?
No, you've got a good point. I mean, parsing kind of in the research community was sort of a solved problem for quite a while.
Because of Yak and Lex?
Yes. And then now there's been sort of resurgence in research in that area because it's like, well, maybe that wasn't the end-all be-all, and maybe we need modular parsers. So that's why working like GLR is really exciting. But kind of getting back to something that what Anders was talking about in terms of, is this a can of worms? Like, do we have to open up the entire language if we want to do this kind of thing? And I don't think we have to sort of go that far to get most of the power that we need. So in C++, for example, we have most of the power we need except for the grammatical extension. But it all comes down to, can you do computations at compile time? Can you manipulate chunks of code and splice them together and things like that? And can you inspect what's the type of something, or what are the attributes of this class? Can you do that at compile time and then use that to sort of generate other pieces of code? I think with those ingredients, then you've got something that's pretty much as powerful as I would want in terms of being able to create new language extensions.
So now you're kind of hitting on another kind of hot topic, right? Meta-programming and so on. Like this is the kind of rage in Ruby, Ruby on Rails, and so on. So when will we see kind of these kind of meta-programming concepts in other mainstream languages except C++?
Well, I mean, I think certainly it's high on my list of things to attack in C#, and as I showed in my talk yesterday, we're rewriting the compiler in managed code, and I'd say one of the big motivators there is to make it a better meta-programming system. Sort of open up the black box and allow people to actually use the compiler as a service, in embedded DSLs, or to write an interactive loop like I did, and to do other meta-programming things, because I mean, I think enterprise apps today live and die by metaprogramming. We may not realize it, but pretty much every app we write has some form of code generation in it, right? I mean, be it XAML or ASPX files or what have you, your OR mappers, configuration mapping files that get compiled into code. There's code generation everywhere. And the tools, and that's sort of the predominant form of metaprogramming that we practice, at least on our platform. And the tools for doing it are terrible, right? I mean, it's like you fire up the compiler and capture an assembly that comes out of it and like do all sorts of wonky stuff. We need a modern approach to that. And so that's something and I think it, like you said, it ties into ultimately, can I extend the syntax? And that might be sort of like that would be the ultimate cherry on top, right? But there's a bunch of hard work that needs to be done first,
right.
And that we can go to work on, and that's sort of what we're doing. Yeah.
So Doug, I have a question for you. You talk about like the good parts and the bad parts of JavaScript, and so one of the things like in metaprogramming is eval. So do you think eval is evil, or is it something kind of wonderful?
Eval, as currently implemented in JavaScript, is clearly evil. Potentially, it could be a force for good, but it's going to require an incompatible change to the language in order to accomplish that. The reason eval, or there are a lot of reasons why eval is currently formulated as evil, but the worst is the security problems, that it makes it even easier for an attacker to hide behavior and insert it into a system. So, dealing with the security consequences of metaprogramming is a big, I think probably the most significant design problem to be solved in fixing it.
Yeah, so if you can kind of go a little bit more detail into that, because if you look at like buffer overruns, in some sense that's also metaprogramming, right? Because people take this.
It's just not predictable.
Exactly, but they take data and interpret it as code in intended ways. So I really is metaprogramming kind of, are we opening up the door for hackers?
I think as you all know, Microsoft builds lots of operating systems, and I think metaprogramming on the system level is a really, really bad idea. So you don't want to open up the box. And having actually the eval in the JavaScript world, so the browser is also a platform like an operating system. And there you actually get all those problems. So in research, we tried to build a new operating system that's called Singularity. And one of the insights was that maybe 80–90% of all the scenarios for metaprogramming you can actually do with compile time reflection and not runtime reflection. And if you do it at compile time reflection, you get all the benefits of static checking and everything else. So in some sense, sometimes we should also see whether there's actually middle ground, whether we really need eval all the way, or whether we can have something in between that gives us more guarantees.
Oh yeah, no, I mean, it's the confluence of dynamic programming and their good metaprogramming capabilities is why we end up seeing a lot of this happening at runtime. But you're absolutely right that most of what gets done could just as well have happened at compile time. It just so happens that our static languages are not quite caught up with in the metaprogramming
Do you agree with that, Gila?
And when you catch up, you'll find out that there's a whole lot of stuff you haven't even dreamed of doing that has to be done dynamically. But setting that aside, I think the issue with eval is very real with respect to security. There's an issue of how you control access to this. And the traditional way where all this meta stuff comes from are environments which never envisaged this wonderful world of viruses and Trojan horses and so forth, and did address this concern. But it's well known actually how to structure things such that this ability to reflect, because it's really about reflection. Metaprogramming is just about one program manipulating another. Reflection is about the program manipulating itself, which is where things really get interesting. And the thing is, you have to control this as a capability. This should not be something that, every object will tell you its class, and the class has this API that lets you mess around with it, which is sort of the approach that the world inherited actually from Smalltalk 80. And certainly Smalltalk 80 is not a secure system, because this idea that you can take any object that someone passed to you and change its behavior on the fly, and incidentally as a bonus change the behavior of all the other instances of that same class, kind of is a little incompatible with security. But there are ways, there's stuff called an approach called mirrors, which are objects that reflect other objects, as you happen to know probably from childhood. But technically, there's this approach pioneered by Self, where the reflection goes into a different object, which is now an object you can control where it goes to and who sees it, and you can use the capability kind of approaches that actually Doug is talking about for using for JavaScript, and that we are trying to use in Newspeak, to control who can do reflection and to restrict it. And so you can have your cake and eat it too.
Anyone else? No. So then, before opening the floor to the audience, I want to ask one last question, and that is, do languages actually really matter? For example, isn't it more important that you have a rich set of libraries, and I think Jeremy already kind of touched a little bit on that, or isn't the IDE really what defines the language, and people don't even care about the syntax because the IDE will do auto-completion for them and so on. So aren't we kind of fixated with languages, with syntax, because we are from the times of TextPad or Notepad or something, and in these new times of IDEs, do languages matter, or is it more the environment and tools that are where you get the bang for the buck?
New times of IDs? I mean, you mean the 70s? So again, I come from a world where the notion of IDE, in fact, one of the reasons perhaps it has problems is that they were so involved in IDEs before people were ready for them. But certainly IDEs matter a lot. All these things matter a lot. I know it's another one of those nice waffly answers. But basically, IDEs are enormously important because they give you tools to manipulate this program. But the language, the level of abstraction you're talking about is also enormously important. And you should have all of these things. And without libraries, obviously, you're not going to get very far. And your languages should let you get at any library you want to, even if it's in another language, right? Things should interoperate. It's just one of the things that you people actually have been doing fairly well, even if it hurts me to say that. But it's very important that you don't live in these closed worlds, and that you actually ideally have an IDE which supports multiple languages and lets them interoperate freely. I think that's a great thing. But all of these things matter, but the languages do matter as well.
But they matter perhaps less in the total sum of complexity than they did, say, 25 years ago. I mean, when I started with Turbo Pascal, there were about 100 functions in the runtime library of Turbo Pascal, and that was about it. And the rest was language, right? And now, in .NET, there's 10,000 types with 100,000 members, and that just completely dwarfs the learning curve of because the language syntax has not grown by 3 orders of magnitude, luckily. I mean, but so frameworks and IDEs just, in terms of the learning effort these days, totally dwarf the languages. But that doesn't mean that languages aren't important. It's just that they occupy a different position in the ecosystem.
So going back to Fortran, the textual model for a Fortran program was a stack of punched cards. C was a major technical advance in that the textual model became a reel of paper tape. And that's still the model for most programming languages. We've had a decade or two experience with hypertext, and we're sort of seeing that kind of come into the IDEs a little bit, but we're still a long way away from a representation of programs that doesn't look like punch paper tape. And my intuition is we'll find some amazing benefits when we figure out how to make it look like something else.
Okay. I would probably turn the question around a little bit. Currently, there are elections upcoming, and like a good politicians, you always change the question that you're asked. So
are you red or are you blue?
Oh God, I wear definitely the wrong color. But what I wanted to say is, I think actually the languages and maybe even the libraries doesn't really matter so much. What you really want to see is what is the problem that you want to solve. And then, based on the problem, you pick right languages and libraries and IDEs. So I worked on GUI design, maybe even with Eric 15 years ago. And at that time, there was suddenly clear that TK was, in some sense, that an ugly language, but it could actually, you could write really nice graphical libraries with it, has a nice abstraction. Was not such a great language, but you could build nice abstractions on top of it. And that worked very well. If you do symbolic computations, I do a lot of theorem proving and this kind of stuff, and abstract syntax tree manipulation, then a functional language is the way to go. If you want to do business applications with lots of different objects and peers and user interfaces, then object-oriented languages might be the way to go. So pick the language and the IDE that's appropriate for your domain, and don't stick to a language and use it for everything that you want to do.
So Jeremy, isn't C++ the kind of universal language that's kind of, has everything that you ever need?
That's right. Well, so one thing we are doing in C++, we're with the new language changes, I would say about 80% of the core language changes are meant to improve libraries. Okay, so in some sense, my view of the language is to serve the libraries, to make the libraries better. And whatever we can do at the language level in that direction, I think is a huge win. Because at the end of the day, I mean, I think several people have said it now, that it's the libraries, it's these higher level services that really what draw people in and let them get the programming job done quickly. So what are we doing? So we're adding constrained templates. That'll help with the reusable libraries quite a bit. We're adding Lambda abstractions. Again, a lot of our libraries take function objects, and now they'll take real lambdas. Static assert lets you give error messages at compile time as part of what your library is doing. So again, these are all things that help the libraries.
So I'm going to make the audience mad because there's one question I want to sneak in that kind of came up, and I want to kind of drill down in a little bit. Is that in some strange way, if you look at a lot of kind of tools that we use, like PowerPoint or Word, or if you use OpenOffice, it's the same thing. The things that we manipulate are structured, except for our programs that are still represented, except for Smalltalk, are still represented as strings. Right? So why is that? So why haven't we kind of evolved to kind of represent programs, really to show their structure? And would that kind of help with metaprogramming and so on?
Sure, but we are evolving that way. I mean, it's like, the expression trees we introduced in .NET 3.5 and C# 3.0 is precisely that, right? I mean,
but we're still stored as strings. When I kind of, quit the IDE, I have a text file.
No, so I think as programmers, it's actually very convenient to manipulate text, and I think that's I'm not sure that that's going to go away. These syntax-driven editors that force you into sort of a tree-ish view and that give you the illusion of having text is just not the right way to work with it. I think history has proven that. But these are just different representations of the semantically identical things, right? I mean, so I don't think we should get too hung up on that,
Well, you should be hung up for it, not on it. But So there is a point that I think there is a reason why this is, and it's simply the lowest common denominator, right? If you put everything in a file, then diff tools can look at it, and they don't need to know anything about the language they're dealing with or the semantics. They just compare at this lowest level of individual characters. So source control systems, sending it in an email, etc. There are a lot of pragmatic reasons why files are actually useful. Where they're not useful is where you're actually interacting with the program in the IDE, right? They're useful for transferring programs among people. They're useful for storing them. But again, a structured view is very useful for where you're manipulating things up to a point. There's a long history of work on structured editors in the 70s that, as Anders correctly said, really failed because they had this idea that they'd go down to the level of individual expressions and it would prevent you from ever having syntax errors or whatever by making you compose sort of almost at the level of ASTs. And that didn't work so well. But when you get beyond the level of individual methods, for example, in an object-oriented program, you find that's a very good line to transition to something structured. You never worry about where the curly braces began and ended. You don't have this 2,000-line file of a large class and start to figuring out where I screwed things up and how much colorization I need to track these and so forth, because you're actually working with a structured view where methods are units that the IDE can boxes for you and you can never step out of them. And it helps you navigate, right? You can collapse things so you can get an overview very conveniently, whereas a file is this long paper tape, as Doug said. So there is, the answer is somewhere of a middle. You don't want a structure editor all the way, but structuring things at some point, there's structure in every language, packages, assemblies, then leading to classes, leading to methods, etc. And most of this you actually will find that if you navigate it in a structured way is really convenient.
Nope.
Dead silence. Wow, that was probably a popular.
Great.
Yeah.
So,
I agree.
I now want to kind of open the floor to the audience. There's mics kind of on the side. First come, first served. So, and what I will do is I will kind of do a breadth first kind of, scan. So I'll start over there.
Hello. So what's your take, guys, on transactional memory and software, hardware, hybrid?
I'm a skeptic at this point with whether software and transactional memory is going to converge. It's been going on for a long time. It doesn't seem to be converging to something that we can use. There are still big performance issues. I mean, I think the best systems I've seen are 2x to 4x performance overhead. If you compare it to other, I wouldn't say but compare it, say, for example, to garbage collection. Garbage collection didn't really become mainstream until the overhead dropped below 10% or so, and STM we're looking at 400%. I'm not so certain that you're not just trading one set of problems for another with locks versus STM, and because STM makes it awfully easy to accidentally start a transaction by putting an atomic around your whole thing, and then you're just gonna like blow off the top, in terms of tracking reads and writes, and so there are some issues with it.
So any ideas from the research community on this?
Okay, I haven't worked myself on software transactional memory, but what I understand is that in some sense it is actually a good way if you want to do if you have only a bounded computation. So don't take arbitrary pieces of code and put transactions around it. But if you just use it for concurrent data structures, that might actually be that might be the sweet spot, and you still have to look for a different mechanism if you want to preserve something else. But so in some sense, yeah, as long as you don't have any external communication, which you can't roll back, or it becomes very difficult, and it's a small amount of data that you have to keep track, then it's much easier to program than using locks, and it's still, in those scenarios, it is actually reasonably fast.
Yeah, something we're looking at Colorado is how to combine transactions and locks, because we sort of realize that it's not sort of the silver bullet, the one solution. So then the next question is, well, how do you get these things to interact with these other solutions that are already there? So.
So another thing is, if you look in the database world, they have transactions with all kind of isolation levels to kind of speed things up. Do you think that that might be so where we kind of, drop some of the kind of guarantees that a transaction gives you to increase performance? Do you think that might be a solution?
Well, but if you look at database system, they are also much more restricted in what operations you can apply to data, so to speak, right? I mean, they have a strict relational model. They do query language. They're very functional, even though they do have mutation. But a general purpose programming language built on top of 30 or 40 years of various locking mechanisms in the OS and whatever, it's very hard for it to not just become yet another kind of locking that you have to deal with, and that's so. Yeah.
And is there any overlap between like static analysis where you can see your side effects and then applying transactional memory to something like that?
I think there are, well, I think what you're perhaps asking here is whether, how do we reason about side effects in a programs better? And the sort of current crop of imperative programming languages that are out there, unfortunately, make it very hard to reason about side effects. In fact, they embellish side effects and tell you to do them at will, right? Functional programming languages, pure functional programming languages completely outlaw side effects. I also think that is not probably the right place to be. It's somewhere in the middle, but perhaps we should be perhaps it should be a little more obvious to people where side effects occur, and perhaps there should be a little more work involved in having side effects. Do you know what I mean? It's like, it sure would be nice if the default was that there were no side effects and you had to do extra incantations to have them. And some of the functional languages are going there. I think that's probably where languages are gonna go.
So it's worth mentioning, like Clojure. It's this new language that's mostly pure functional, and they're doing some interesting things with transactions in that setting. And I think they're making some progress on the performance issues because they're able to sort of make these assumptions that there aren't going to be side effects for large parts of the program. I think that's sort of making it much more feasible. In that
Islands
setting.
of purity,
Yeah, so maybe there's a small reference to recent work that we did for game developers, where we started out with the idea to give them actually transactional memory, so they compute new worlds and then we'll merge them. And then it turns out that transactional memory is actually a little bit too strong. So you don't want to have, in some sense, one player win over the other by taking over, in some sense, the updates of the world. But what you really want is actually merge of the different memories that they work in for a new to compute a new world. And so there is actually taking the idea of a transaction, but instead giving the users the flexibility to define the merge operation instead of rollback, and one person takes it all.
Okay, so I'm going to move to that side. Thank you.
I easily have like a million questions, but I'll ask one.
Well, you can go and then join the pew in the back. So
a million times. Yeah.
It kind of follows on that one, where the longevity of languages. You see how COBOL started as the business language, and then 10 years later Java was introduced, and nobody continued using COBOL, and now Java is more than 10 years old. And I'm starting to see where you're adding things to languages, and it gets it to be too difficult. I wonder, why do we have to keep on adding to this language? An area where I see it works really well is the web, where we have JavaScript, HTML, and CSS. They have their specific areas that you can work in. I can have multiple people on a team, one person who's really good with style and design, and another person who's good with behavior and can understand how to program a functional language. And you can't take the person using Photoshop and make them program. So why do we have to keep on adding things to language? Why can't we break things up into sort of the mindsets that people work in? So not one person has to know everything.
Right. So I think there's a tension in a language, particularly standardized language. The community generally benefits from stability, hugely. I mean, having a language which is wiggling all over the place is tragic. But because this whole thing is driven by style, there are new accessories which are always becoming available, which are shiny and neat, and it is fun to put them in. And generally they're put in by committees, and committees are not empowered to take things out. They can only put things in, so they do. And so a consequence of that is over time a committee will lose focus and then start bloating the language, and there's a good chance that the language loses a lot of its attractiveness as a consequence of that.
So should languages be designed by committee, or should we have like a benevolent dictator, you know?
Dictators, yeah. Absolutely.
Dictators, absolutely.
So, I mean, I don't know, I think that's, saying that it's only sort of fashion that is why we add features to the language, I think is kind of cynical. I mean, I have a...
Absolutely, and let me continue. So a community that uses a language is like a business, you know. So when a language is small and experimental, it's like a startup. And a startup is allowed to do crazy things and
like
can take huge risks.
4?
I'm sorry?
Like ECMAScript 4?
I'll be getting to that. So, but once the community gets big, it's like a big company. And big companies have to be stodgy. And even though a big company might want to claim that it's really innovative and all of this stuff, it really can't. It has to have constraints on its ability to innovate, because if it gets too wild, it'll throw itself apart. And so you may have controlled pockets of innovation, but the main thing has to have structure. And we have a similar kind of thing in this community, that the more people you have using a language, the less license we should have in modifying that language. When it's a small group, then it doesn't matter. In fact, you might know everybody in the group. And even that doesn't work. Like at Bell Labs, they knew everybody who was using C, but they added double ampersand operators and didn't want to bother the couple of guys who had written some old expressions. And so we have incorrect precedents built into that language. One of the places where ECMAScript almost went wrong was they went wild and crazy, thinking that they would make the language more popular, not really understanding that it is probably the most popular programming language in the world right now. And they were thinking if we just add classes to it, we'll push it over the top. But they were already there. So what they were really hoping to do was to get more respect for the language. Because even though more people are writing JavaScript than any other language, most of them hate it. And they were hoping by putting enough stuff in that they would learn to love it and then love them. But there's no love in the JavaScript community.
Okay, so shall we go to the, because there's a long queue of so let's go there and then...
Okay, so when I think about domain-specific languages, there's really two reasons for creating one. The first one is that the language tools that you have at your hands are inappropriately expressive. They're either too expressive, they give too much power to what you want to do to restrict, or they're not expressive enough for what you want to do. The second reason as well is kind of fun. So whenever I start looking at creating my own domain-specific languages, I find out that the tools are awful. They are continuously awful. It's like when Mike Lesk gave me my first copy of the manuals for Lex and Yak 28 years ago, and I was looking him over and playing around with creating, I can create cool little stuff. What the hell is a shift reduce error? And the problem is that the expression of this and the tools are all awful. When are they going to get better? When are we going to have reasonable tools so that my domain-specific language doesn't suck because the tools suck?
Well, I think they just got better. I mean, I would hope they just got, the whole Oslo thing is exactly about what you're talking about there. And the ability to define your own grammar with M grammar, you know, and like, I mean, I don't know if you saw the demos yesterday of the three-pane viewer where you literally live can modify the syntactic or the semantic grammar of the language and see syntax go from DSL to the final output ASTs, you know, like interactively. I don't know that has ever really existed before. So I think the tools are starting to make some progress there. That's not to say that we're done, but I think we've gotten, you know, a very interesting, good first step here with that tool set, at least.
All right.
My question is, can structural types and type inference bridge the gap between dynamic and static languages?
Great question, because that's a topic that we haven't touched at, right? The tension between static and dynamic typing. And structural types are beautiful. So
I'll be short.
let's geek out.
I'll be short. No.
Oh,
No, I don't think they can. There's a difference between, because implied in what you're saying is that both are typed. You know, and there are lots of things out there, and so structural typing is one kind of static type, and then you know, and say classes and whatever is another form, or nominal typing is another form of static typing, right? But a lot of, I mean, increasingly we're seeing stuff that is just inherently not typed. You know, like look at all the Windows Azure stuff yesterday, and everybody talking about building REST interfaces to the cloud, right? Well, REST interfaces are by definition have no schema, and indeed they were in a sense the uproar against the complexity of WSDL and all of the strongly typed web services, right? Let's just restify it and just have URLs and whatever. Well, tell me where I'm going to get the schema for that, right? And if I don't have a schema, then, well, now we can either debate whether it should be super painful to get at it, like, you know, you got to, like, open a web response and add some byte array or blah, 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 or whether you just should be able to dot into the web service and write, you know, the or slashed or dotted form of the URL sort of as part of your language. But it wouldn't inherently be dynamic. Do you know what I'm saying? So I think the answer is rarely at the extreme, you know, when it comes to it. I think it's crazy to say every language should be statically typed all the way down, or we should just toss types. I mean, it's neither are correct. It's somewhere in between, and it's really the interesting thing is like having a good marriage between static and dynamic and being able to seamlessly flow into the dynamic world is I think, the important way.
So I think there's one misconception that type inference is the way to bridge the gap between static and dynamic. But type inference doesn't do that. It just gives you a different flavor of static where you don't have to write the types down. But that's sort of this syntactic thing that actually doesn't matter that much. The real flexibility from these dynamic languages is in the fact that there isn't actually restrictions on what you can write at compile time. And I agree with Anders that what we really need is a gradual type system that lets you mix between real dynamic typing, where the checks happen at runtime, versus static typing, where you actually have the checks. And you should be able to choose between the two on an expression by expression basis, on a parameter by parameter basis. You shouldn't have to say this one module is statically typed, or this other module isn't. It should be free to you to choose.
Okay.
So Gilad, what? Oh,
maybe I can.
Go ahead.
Since I just want to pick up Jeremy's idea. So what type systems actually give you is in some sense some decidability about what values your program at runtime will have. But in some sense, that it's a type system is exactly the reason why that we can decide everything at compile time. If you actually open the box up and says, okay, type systems are partial correctness, so what is the other way that we describe partial correctness? It's typically contracts. And so in contracts, you can actually say, oh, X has this type, or X is greater 150, or X is a prime number. And these are completely three different kinds of properties, but they can all be nicely expressed as contracts for pre- and post-conditions. So I think if you want to have really this fluency between dynamic and static, maybe that's actually where we should look at.
Gilad, do you have anything to say about static versus dynamic types?
Oh, maybe. But the thing is, I believe I was asked here in order to bring controversy and kind of mess things up, and I'm doing my best. I try to insult and everything as much as I can. Unfortunately, in this case, I actually agree exactly with what Anders said. The short answer was no. And basically everything else that's been said makes perfect sense. Sorry to say.
Okay,
Thank you.
give you something. So we're kind of, swinging back to the front here on the left.
Hi. Questions about adding features onto languages. You mentioned earlier about how languages aren't evolving quick enough. Is that at odds at all with the need to do? Sorry. Phrase that. I was thinking of Link, where the query syntax appeared in C omega first and then C sharp later. Do you think that's a good way of adding features where it like evolves in a small language first and then gets moved into a major language later?
Yeah, I mean, I personally think that's a great way to experiment. I think another interesting pattern that I'm very fond of right now in terms of language evolution is this notion that our static languages and our programming languages in general are getting to be powerful enough that with all of the stuff that we're picking up from functional programming languages and metaprogramming, that you can sort of, in the language itself, build these little internal DSLs where you use fluent interface style and you dot together operators and you have deferred execution and whatever, where you can, in a sense, create little mini languages except for the syntax. Like if you look at parallel extensions for .NET, they have a parallel.for, where you give the start and how many times you want to go around, and a lambda that is the body that you want to execute. And boy, if you squint, that looks like a parallel for statement. Do you know what I'm saying? But it allows API designers to experiment with, different styles of programming, and then as they become popular, we can pick them up and put syntactic veneers on top of them, or we can work to make, languages maybe even richer and have extensible syntax like we talked about. So. But I think I'm sort of encouraged by the fact that our languages have gotten rich enough that you can do a lot of these things without even having to have syntax.
So to kind of couple this question back with the kind of the previous one about contracts. So contracts have been around kind of for a long time. They have been in IFL and in Spec Sharp and so on. Do any of you see kind of contracts kind of appear in the kind of real languages anytime soon?
I like them a lot. I hope that they do.
Yeah. So obviously, I'm a big fan of it, and I think Anders is right. What language designers typically do is, so either they venture out and build new small languages with small communities, and maybe then it's picked up. But if you actually take existing language and you just add delta on it, try to do the deltas as libraries. And so while we did all the Spec Sharp work where we really showcase how it could look like, I think there's a much easier way of entrance. And the good news is, so we have now a library solution for contracts, and that will ship in .NET 4.0, and there will be actually a DevLabs download where you actually can play with contracts for any .NET language. That's the beauty of having actually a library solution instead of language solutions, because then it works for VB and it actually works even for C++, the managed C++. In some sense, yeah, I encourage you to play with language ideas, but put them as libraries first, because it's so much less painful than build your own library, because you have to build also your environment and everything else. So contracts are a great idea, and hopefully we'll see at some point some syntax, but we have our king in the room and he has to decide.
Okay, so something that maybe ties together a lot of what we've been talking about. Gilad mentioned that people are apt to keep banging their heads against the same syntax rather than learning something new. And a lot of the discussions that we've had have been really focused on even marketing and adoption for a single language. But now that we're seeing all the dynamic stuff added to C# and really the recognition that we're in this multi-language kind of world, what sort of social or educational kinds of things can we do to make it easier for developers to recognize the value of having multiple languages? Right? We constantly struggle with, I've been doing this for 20 years or whatever, and I'm going to keep doing this language because it's the language that I know. A lot of us in here are probably people who enjoy learning new languages and playing with them and stuff, but how do we kind of sell that as a whole, as opposed to saying you should use my language rather than you should use these languages to accomplish this goal?
Please tell me.
Right, so I do have a potential solution, but it's kind of trivial stuff, and it's like, well, clearly Microsoft has a lot of influence and weight, and stuff that they put out is good. So examples of large, successful, real applications that make use of different languages and different paradigms would certainly help. You know, you can say this is a good project, it worked, it was, you know, here's why this was beneficial here, here's why this is beneficial there. And then there's the earlier on educational aspects, but I think we have to recognize too that not everybody who's doing programming has formal CS education and that kind of thing. So,
yeah, no, I mean, I look forward to getting some F# case studies out there and some Iron Python ones as well, you know, absolutely.
So something that comes to my mind in this context is that in some sense, as soon as you're building bigger applications, there are rarely applications that are written nowadays in just one language, right? So if you have any application that runs on the server and the client, oh, there is a JavaScript and there is something else in the background, right? Whether it's Java or whatever. In some sense, I think if you are actually also in your position more fluent, then if you actually work on this project, just work on a different sub-project, and they might actually use a different language, because with distributed programming, in some sense, you have enough decoupling that things will be written in different languages.
Yeah, well, and I think the JavaScript example is one that I've used before to try to say, hey, look, you're already using different languages. But I think that's back to another point, which is a lot of people don't consider JavaScript a real language. It's like, you know, I write a method at a time. Right. People aren't looking at these whole program kinds of things.
Part of it is, in general, I recommend everybody learn lots of languages. There's a tendency for a lot of developers to learn one, whatever it is, and just stick to that. And you're better off to learn a variety of them.
Well, I think it's definitely clear that that's the case. But how do you convince sort of the career enterprise developer that that's a worthwhile thing to do beyond beating them over the head with it and that kind of thing?
If they don't, their job will go to Bangalore.
Okay. Next question.
Actually, in C# 3.0, we introduced to lambdas, which actually comes as a response to link. In 4.0, we introduced to dynamic operators and dynamic variables, and then dynamic operators. So why actually static language want to be dynamic? I mean, I saw JavaScript programs with 2 million lines of code, which is absolutely unmaintainable. But it's an incredible program, because in C# it can take about 20 million lines of code. But it will be maintainable, and without memory leaks and such stuff. So
anything with
the
20 million
question
lines
is, why C# wants to be JavaScript at the end of the day?
Because we're out to co-opt the world. I mean, it's fashion. Okay, so the brief answer there, from my point of view, is that we're not adding the dynamic capabilities to C# in order for people to throw away all their statically typed code and now go rewrite it as dynamic code. We're doing it because increasingly there are many interesting things out there that you want to talk to, like the JavaScript DOM, or like Iron Python, like Ruby, like REST services, like XML documents, that are inherently not statically typed. And we can either just sort of sit back and go foo-foo at that, and now you're going to have to write some way of interacting with it, and each of the different domains end up with their own way of you know, in XML it's get element of blah, or it's invoke member of this, object array of arguments, or whatever, and there's no commonality, and we can actually build a common solution for talking to those environments. I mean, at this point, you know, C#, it's interesting. With the dynamic capabilities you saw me demo, you can almost cut and paste JavaScript into C#, you know, and then just change a few places, because, and I think that's super useful. I really do. I mean, I think it saves you from just banging your head against the wall on some arbitrary interoperability API, as opposed to actually getting your problem solved. But my view is that, you know, view the dynamic as an extra tool. Don't view it as You know, just like you view the functional capabilities in C# as an extra tool. Don't view them as, now I must rewrite everything in that style. That's
We
not.
speak about developers. I mean, I saw the code that something like var something equals bring me something as function, which is absolutely unmanageable today in C#. I mean, we don't know what is returns. So when it turned to be dynamic, developers go to build everything dynamic in C#, and then we'll get actually something.
Well, but they're not going to do that. I mean, because they care about performance enough, and they care about statement completion, all the things that you get from static. And I think var and type inference, you know, for local variables, I am convinced that it is valuable. There is no, I mean, because, you know, C and then C++ and Java and then C# previously, you know, they just force you to state the type too much. What is the point of saying new dictionary of string, object, my dictionary equals new dictionary of string, object. Didn't you just say that? I mean, so why not just say it once? You know, there are so many cases where it's bloody obvious from context what the type is, and you don't care. So anyway.
So I'm sorry to interrupt.
Sorry.
We are getting kind of caught up very soon, so I want to give the panelists one last chance to kind of, you know, drive some message home that, you know, you want the audience to remember. So now let's start from, you know, the other side.
Let's start from
or start from that side.
Okay. Well, actually, on the same topic we were just
very
talking
short.
about, I think one thing we need to recognize is that in different stages of development, dynamic versus static typing is more or less appropriate. So like when you're prototyping something up, you don't want the types in your way. That's when dynamic typing is extremely valuable. Once you start to get to the larger scale, you've got different modules, different people working on different parts. You want to start to solidify some of those interfaces and put types on them. So I think having both is...
Wolfram.
Okay. I would actually just encourage you stay tuned. So we will work on languages in my team, and you can go to the research.microsoft.com/rise website in order to see what's going on. So we'll have some videos of the stuff that we are doing. We will give out some code that you can play with, and then let us know what you think, whether certain directions in language design work out or whether they don't work out.
Doug.
A few years ago, dynamic languages were definitely out of style. Today they're in. I mean, it sounds like fashion to me.
Okay, Gilad.
So I think you're going to see a lot more convergence between ideas in the sort of dynamic language world and the static language world. And that is something to remember. Learning lots of new languages is good for you. Even if you program mainly in one, is the other thing to remember.
And Anders?
Yeah, no, I would second that. Go pick up F#, go pick up IronPython, play with them, learn from them. You know, I personally learned a lot from playing with those, and then it makes your mind think in different ways, and that's always healthy. Yeah.
Okay, well, thank you very much.